NVIS has been around for a while. There are still people who claim that it doesn't work, that it's just ground wave, but it's just not true. It is working. It's been proven that it works. During World War II, the German army had a particularly difficult problem, which was they just didn't have the wire to spread all over the world, that the pieces of the world that they had captured. And how do you control, for example, in the African desert, how do you control the troops on a 500-mile front? And their answer was NVIS. If you've ever seen any pictures from World War II, you know the name Erwin Rommel was their general in North Africa. And anytime you see a picture of Erwin Rommel, almost always somewhere in the background was a vehicle that looked something like this. Think of like a flatbed truck with a big piece like that, two big pieces like that. That was his NVIS antenna. And he could control troops over hundreds of square miles. And that's what they were doing. The American Army had a lot more wire, so they mostly ran wire. Also, the American Army didn't trust their crypto systems as much as the Germans did. As some of you may know from history, that was a good thing because the British had broken the German crypto systems, and by using that NVIS, we were able to read a lot of their mail. Okay, so it's not new. NVIS was also used heavily by the American Army in Vietnam. One of the advantages in a combat situation is, as you'll see, the signal goes straight up and bounces straight down, so you can't really do radio direction finding on it. So the enemy can't radio direction find and then lob over mortar shells, because it's going to say the signal's coming from up there.
Isn't this known as cloud warming?
Yes.
I mention it now because it may clarify.
Yeah. I mean, it's used, we refer to as cloud warming when we have antennas that don't perform very well and have too steep a takeoff angle when we don't want it. And we say, well, that's just a cloud warmer or a cloud burner. But it has real value. You can get very good communications in an area the size of the state of Connecticut. Or let's say the northern half of Arizona or something like that. If that's what you're trying to do, if you're trying to run a network or talk to friends, that's a good way to be able to talk to them.
Yeah, I used to run my Wyndham was like at 30 feet, and I would do the 4 p.m. net on 80 meters, in which I'd be talking to folks between Connecticut, Long Island, and Maine.
Yeah.
And that all worked pretty well.
Yeah, and it'll work if you do it right. Most of us are doing NVIS on 80 meters and 160 meters because we can't get our antennas up there.
Right, exactly.
So whether we like it or not, we're doing NVIS. In NVIS, the RF is launched at a high elevation angle, greater than 70 degrees. If you think about when you're doing DX, you want a low takeoff angle. They talk about things like 17 degrees or 20 degrees, so it goes way out to the horizon, hits, bounces, skips, hit, bounces, skip. In this, you're sending it straight up, it hits a certain spot in the ionosphere and comes back down again. Spreads out almost like a rainfall pattern. It's almost like if you take the garden hose and you spray it straight up, you get a nice rainfall coming down. Okay. Generally speaking, 1 to 300 mile radius of the transmitter, depending what frequencies, conditions, all that. You'll hear people saying, well, I was doing a 700 mile NVIS. No, you weren't. If you even say that, you're an idiot, you don't know what you're doing. Now, there's certain critical frequencies, we'll talk about that. As it turns out, the NVIS, the attenuation can be much less than on DX. You can get 5/9 signals very easily because you're not going through the pieces of the ionosphere that attenuate the signal. So it has some interesting characteristics, operating characteristics. We'll see that in a minute. But here's a slide. I mean, this is the concept. Look, your signal goes straight up, bounces straight down. Okay, when you're doing DX, you're doing something like this: bounce, 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 to get over there. And these are the various layers of the ionosphere, or some of the layers of the ionosphere. The D is one of the critical layers because that's where a lot of its signal attenuation happens. So look at how much time the signal is spending in the D layer versus how much time it's spending here. Okay, In order for its frequency must be less than what's called the critical frequency of the F layer, which is sort of a tautology, because the critical frequency of the F layer is the frequency at which NVIS works. So, in order for the NVIS signal to be returned to their surface, its frequency must be less than the frequency at which NVIS works. Duh. Well, yeah. Okay. But what happens is there's a certain layer in the ionosphere that will bounce if a signal is shot straight up, it will bounce straight back. It's called the F2 layer. Depending on where that layer is, which depends on heat, depends on time of year, depends on your longitude, that frequency can be anywhere from 5 to 15 megahertz. In fact, it can be anywhere from 1 to 15 megahertz. So it depends on where you are, it depends on the time of year, it depends on the time of day, it depends on the heat. But if you find the right frequency, you can get good NVIS communication. Andy, you look. Oh, okay. Okay, typically during the day, you're going to be up around 40 meters, 30 meters. Typically at night, you're going to be 60 or 80. During periods of low solar activity, during the heat of the summer, it could be even worse. What's the matter, Tom?
Nothing.
Okay. Is there something I should know? No?
No.
Now, it does mean that you have to be able to shift frequencies. You have to be set up to shift frequencies. It's not going to work if you just have an 80-meter antenna. One of the nice things about NVIS is that it's low noise. A lot of the noise that you pick up on a regular HF transmission is not there. So you can get better quality. It doesn't mean that it's not going to pick up thunderstorm, lightning, and all that kind of stuff. But a lot of the other noise will be there. And it won't pick up a lot of terrestrial noise. It's very good, as I said, for emergency communications. You can do CW, you can do voice, you can do digital modes, and you can have very reliable kinds of communications. One of the things you have to have is frequency agility. If all you've got is an 80-meter antenna, it ain't going to work. Okay. If you've got an 80, 40-meter antenna, an 80 and 40-meter antenna sitting up too high, it might work on 80 meters, but it'll be too high for 40 meters. And this is something you see a lot, that people set up an antenna, they have it like 40, 50 feet high, which is okay for 80 meters, we'll see why in a minute, but doesn't work at all for 40 meters, and then they can't understand why it doesn't work. It's got to be low, and we'll see that in a minute. This is just repeating the concept of, at different times of day, you may be on different frequencies, on different bands. And this is just, I don't want to go over this in detail, but what they do is they've got some rules and regulations for how they operate. When they're going to go up, when they're going to go down. Standard 100 watts is fine. The key is the antenna. And the antenna, okay? The antenna should be horizontal. There is no such thing as a vertical NVIS antenna. Because what you're trying to do is bounce the signal straight down to the earth and send it straight up. Whereas verticals don't do that. They send it out that way. The antenna should be between 0.1 wavelength and 0.2 wavelength above ground. So if you're on 80 meters, that means your antenna should be somewhere between 24 and 48. I'm sorry, it comes out to, it should be between 8 and 16 meters above ground, which is approximately 24 to 48 feet. On 40 meters, you're talking about the antenna being between 4 meters and 8 meters above ground. 4 meters is about 16 feet. So you're talking about being 16 feet to about 32 feet above ground. If you've got a 40-meter antenna up at 40 feet, it's not going to work for NVIS. It's just, it's just not. But you find a lot of people who go, well, I've got an NVIS, I got a wonderful NVIS antenna. My 40-meter antenna is up at 60 feet above ground. It's not an NVIS antenna. There are issues about if you have the antenna much below 0.1 lambda, 0.1 wavelength above ground, you start rapidly losing gain. Although we've discovered, quite by accident, that putting a wire directly underneath the antenna will suck. A wire that's not attached. You take your antenna, you put it at about 0.05 wavelength above ground, and you run a wire, just lay it on the ground, just a piece of wire. It doesn't have to be attached to anything. Solves a lot of that problem. Not sure why, but it does. And you can do an inverted V with only one support. A standard antenna that the military uses, what do I do with that thing? You've probably seen pictures of it. And I can't remember the name of it. It's an inverted V looking from the side like this. And there are two more wires coming out. Looking from the top, if you're looking down, what you see is there's your 80 meter and there's your 40 meter. They're at right angles to each other. This is up at about a quarter wavelength. This is down near the ground. The ends are down near the ground. You need one feed line for the thing. You don't have to have separate feed lines because the resonant piece, the piece that is resonant at whatever frequency you're using, is the only thing that's going to transmit. And you can make these things for about 75 bucks. You can buy them for a couple $100. John, N1OLO, is now selling it one for about 80 bucks. And it's basic concept of you have your different wavelength antennas at right angles, and it works.
How high is the feed point for NVIS?
The feed point would be up here on either of these antennas.
But I mean, above the ground.
Well, on this, the feed point, if you're doing the inverted V, the feed point can be a quarter wavelength.
You'd have to, that antenna wouldn't work as NVIS for both frequencies without adjusting the height of the feed point.
Oh, no, I see what you're saying. The ones that work on 4080 do okay this way because so much of the antenna is low, yeah. Yeah. So that works out okay in this case. You typically set it for what most people do is they set the center up at about 20 feet, and it works for both of them, maybe 25 feet, which is not necessarily a quarter wavelength, but it kind of works out. But you can build these things and experiment with them. And notice people should be kept away from the ends of the antenna, because on a low antenna like that, the ends of the antenna are reachable, and as you all know, there are very high voltages at the ends of dipoles. Let's not bother with that one. Standard wire, no big deal, right? It's just no big deal. If you're using an inverted V antenna, you can get yourself into about 90 feet of space. It'll work just fine. These are just some of the numbers of your standard dipole lengths. It is suggested that you feed it with lateral line, but that's not necessarily true. If you're going to use one dipole, you want to feed with lateral line because that gives you better SWR. If you're using one wire for multiple bands. If you're using something like that with multiple wires, then you can feed with coax because you're going to be resonant on each band. But you know the general concept of on the dipoles, if you feed the dipole with lateral line, you'll be able to get a better tuning on the different bands. You'll get less loss even as you go from 80 to 40 to 20. So that's why you see a lot of antenna designs, multi-band antenna designs fed with lateral line for that reason. Loops, you can use a one wavelength loop. and you can make portable antennas. For example, you can have a wire attached, you can have a wire bent over your car, take the mobile whip and bend it over your car, or take your mobile whip and then run a wire out from it across to a tree and make it an L, and that'll work for NVIS. An L will work for NVIS. It's not as good, but you can make it work. Any, use short dipoles, any metal objects, fences work, metal chain link fences, as long as the fence isn't grounded. If the fence is grounded, then obviously it's not gonna work real well as an antenna. Elena?
So it can't go on something more than 10 to 15 feet above ground?
It depends on the frequency you use it. You wanna have, parallelogram, not more, well, I think that's probably not well stated. It really, you still stick with the 110 wavelength above ground. So again, if you're on 8 meters above ground, which is 24 feet. If you're gonna be on 40 meters, you're talking about 4 meters above ground, which is about 12 feet. You can go up to 2/10 of a wavelength above ground. So 2/10 on 40 meters, 2/10 of a wavelength, I'm sorry, 1/10 of a wavelength of 40 meters is about, not 12 feet, but 16, 15 feet, so between 15 and 30 feet on 40 meters. It depends on the band that you're on. The rule of thumb is 1/10 to 2/10 of a wavelength. If you put a wire underneath your antenna, or you put another dipole directly on the ground underneath your antenna, it solves some of the problem of if you're down real low, if you're less than 1/10 of a wavelength. And I once read why it works, and I don't remember. Sorry, but it does work. As we said, you can set it up real quickly. It doesn't require any special equipment. We've run tests from Sterling Farms. We threw a dipole up in some trees up at Sterling Farms. Did nicely. We run a test from the 4th floor outside plaza, outside of the cafeteria. There's an open air seating area. It's essentially the 4th floor. It's essentially the roof of the parking structure. And we set up an antenna, and it worked real well. We did it, so from this building and up at Sterling Farms, where the city has its main communication antenna, there's enough trees, you can throw an antenna up 20, 30 feet, that's all you need.
Are there NVIS nets, like local?
There are some locals, there aren't any per se in this area that I know of. There may be people doing it unofficially. You would wish that Connecticut Aries would be smart enough to do something like that. They have their 80-meter and 40-meter nets, but they don't make them NVIS nets. So you've got people with verticals, you've got people with antennas that are 60, 80, 100 feet in the air, and then they don't understand why they're having trouble talking from Hartford to Stanford, or Hartford up to whatever's in the north, stores or something. Or technically Middletown, because that's where the net control would be. In other states, they use it very effectively. Army Mars uses that. Most of their nets are state nets or half state nets that rely on NVIS antennas. Out in Arizona, my brother belongs to the Coconino County Sheriff's posse. That's what they call it, the posse. They do search and rescue. So what they'll do, they'll go out into, it's mostly national forest out there. They might have an area that they're searching that's the size of the state of Connecticut. Coconino County itself is 3 times the size of the state of Connecticut. So they'll have a report that, someone is lost in the area of the Grand Canyon. That's an area the size of the state of Connecticut. What they'll do is, they'll drop in a couple of people to set up NVIS HF stations on some hilltops, and then they'll set up 100-watt VHF radios with a nice tall vertical whip, and that's how they do their communications. And then they'll do the search, and the searchers are down on horseback or jeep. They're talking VHF to the nearest hilltop, or a hilltop within 10 miles of them, and then that hilltop is talking back to the base on an HF radio using NVIS. So it's really kind of neat, and that's something they do. In the summer, they're out there sometimes twice a week doing searches. And it's literally, somebody, I know that there's somewhere, they started out in Sedona, and they've been gone for 2 days, and they were supposedly going north. You've just defined a search area that's about, you've defined a search area that's as big as Fairfield and New Haven counties together. That's the way they do it. So it is kind of neat. And that's it. I'm not going to bore you with the rest. It's fun to do. It's something different to try. We all play with the DX antennas. Play with something else. Try something else. It's kind of neat, and you can get some very nice regional communications. If you have friends in Massachusetts or Connecticut, and you want to talk to them, that's a great way to talk to them. So just something different, and it's a good trick to have. And, like I said, we have it available. We can do these kinds of things if we ever have to talk out of here. If Echolink goes down and we have to talk to Middletown, that would be the way to do it, if the internet is down. By the way, Connecticut Areas has set up 8 WinLink stations that are piggybacking on the state police communications network. So we now have 8 VHF WinLink stations that we can talk to. The problem is they're piggybacking on the state police communication network, which is not internet, but it's wired or at 700 megahertz radio repeaters. But if they need us because that network went down. So it's sort of like, guys, what part of backup are you missing? By the way, WinLink does have some has HF stations set up for NVIS. They're scattered all over the country. The nearest one is up in Massachusetts. Well, no, there's some closer ones on the ham radio side. There's one in Connecticut. There's one on Long Island. There's one up in the Catskills. There are a couple. There are about 10 of them in about a 150-mile radius, and they're set up for NVIS communications on HF using WinLink, and they're very reliable. I test the one up in the Catskills every week or so, and I send messages through it. Always 5.9 communications. And it's just, he might as well be sitting next to me. And it's, and he's on the other side, by the way, he's on the other side of Hunter Mountain. So Hunter Mountain is between him and us. I'm getting 5.9 communication. So, okay, that's about it. We're trying to get somebody from Red Cross to talk to us next month. Next month, our meeting will be the regular first Thursday of the month. So that's about it. Anything else, Ernest? Anybody else? All right. Thank you all. Yes.